This is another video in the series Trig by Heart. This is just a quick review of Sohcahtoa. Sohcahtoa. Basically, this stands for sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. That's Sohcahtoa. Okay, and we're going to do a few examples here with a 3, 4, 5 triangle. A 3, 4, 5 triangle has this angle here of 37 degrees. A lot of times we call this angle theta, which is a Greek letter, and we often call angles Greek letters instead of Roman letters. So let's say that we are going to find the sine of this angle. Remember that sine is opposite over adjacent. So the sine of theta, or the sine of 37 degrees, is equal to the opposite from the angle divided by the hypotenuse. Remember, the hypotenuse is the slanted side, and the right angle sides are called legs. So the opposite leg is what you use for the numerator of sine, and the hypotenuse, which is the slanted side, you use for the denominator of sine. So in this case, we're going to put 3 divided by 5, which happens to be 0.6, right? So the sine of 37 degrees is 0.6. What about the cosine of 37 degrees? What's that? That would be the adjacent over the hypotenuse. The adjacent would be the leg that is next to the angle that we're asking about, which is 4. So it's going to be 4 divided by the hypotenuse, which is the slanted side. It's going to be 5, which is equal to 0.8. Finally, tangent. The tangent of theta, or the tangent of 37 degrees, is equal to the opposite over the adjacent. So we already know that the opposite is 3. We know the adjacent is 4. So the tangent is 3/4, which is 0.75. Okay? A lot of times the way we use trigonometry is we can figure out maybe we know that the side of a building is 30 meters tall. And then we know that the sidewalk in front of the building is 40 meters long. And we want to know what this angle is. How can we figure out this angle? Well, we know that if the tangent, the opposite over the adjacent, is 0.75, we know that the angle must be 37 degrees. So you can use it in reverse. Okay? Alright. Now I'm going to give you something that's a little bit different. What if I gave you a triangle and I said that the hypotenuse was length 1, and I said that the opposite was 0.6 long, and the adjacent was 0.8 long. Okay? Once I do this, you might recognize that this is in the same proportion as a 3, 4, 5 triangle. 3, 4, 5 triangle. Do you see how they're in proportion? But what I've done is I've made the hypotenuse 1. And so I've reduced the size of the legs also. Okay. Now do you see that since I have the hypotenuse equal to 1, if I was going to do the sine of this angle, I would put 0.6 over 1, which is just 0.6. And if I was going to do the cosine, I would do 0.8 over 1, which is just equal to 0.8. I don't need to divide by the hypotenuse because the hypotenuse is 1. That makes it a lot easier, doesn't it? Now I can just say, hey, I can just look at the opposite it's 0.6, that's also the sine. I can just look at the adjacent. It's 0.8. That's also the cosine. It's a lot easier to figure out the sine and the cosine if the length of the hypotenuse is 1, right? Because I don't need to divide. Okay, and that's the concept we use in what we call the unit circle. In the unit circle, the radius of the unit circle is 1. So whenever we figure out the sines and the cosines, we can do that just by figuring out the height and the width of the triangle, and that's going to give us the sine and the cosine. That's it.